As I told you, in this session, I'll be taking you guys through the benefits and the fundamentals of building information modeling with an existing model and with an existing structure in UAE, which wouldn't have been this effective without the application of BIM. So, first of all, I'll introduce myself. I am Nahla Fatima, BIM Application Engineer at BIM Labs Global, Dubai. So before moving into the session, I'll just brief about our company, BIM Labs Global, and what are the services that we provide. So BIM Labs Global has mainly 3 departments. That is BIM, we provide BIM training, then BIM training, BIM implementation, BIM placements and all. So in the BIM training departments, we train the students, corporates, working professionals, graduates and all. So there are different, syllabus. We have set different syllabus. So depending upon their needs, we'll take classes for them. And there is BIM implementation, where we help we work closely with the organization and help them to implement building information modeling in their organization by training their officials. Then there is our project team itself, that is the BIM studio, where we have a team and that's the projects of the clients. Clients will give us projects and we'll do the projects. So we have our own team, project team. And there is BIM placements, where we provide placements for students who complete the course in our institute. So right after the course, there will be a 3 months internship. Meanwhile, the students will be placed to the companies that we have tie-up on. And also we provide 100% assurance for placements for the students. And I'll move on to certain certifications that BIM Labs Global has. We are actually authorized academic partners of Autodesk. And also we have the Indian Green Building Council certification, which is a certification for sustainability. Then we have the Bentley certification. Bentley is a parent company of StatPro, which is a structural analysis software. We even have a professional membership in India BIM Association and several other certifications. So not going much more into that, let's go into our topic of the webinar. So, building information modeling. So do you guys know what is building information modeling? Are you guys new to this topic? Or is it the first time that you hear this? Maybe not the first time, I know that. So if anyone knows something about this, you can just speak up. Or you can even write in the chat box. No one knows about it? Okay, I'll tell you. So building information, I'll just explain it to you in a simple way. Building information modeling is nothing but it is a cyclic process in which we can actually, it is a just general construction. It's based on construction. So in this process, we can actually model softwares, actually model buildings virtually, just as how we can feel the buildings, just as how it looks like on the site. We can make the buildings just as how it looks, as how it looks on the site. We can feel, we can do different, the material properties, everything. We can assign everything and we can extract informations from this model. That is another, interesting definition that I've heard about BIM is that BIM is building of information models. That is, we'll get the models with information-rich models. So you guys will get more about it at the end of this session, because I'll be explaining more in detail. So let's move on to the case study that I told in the beginning. So do you guys know which bird is this? Just interact, okay, because then only the session will be interesting for you guys. So I hope everyone knows which bird is this, but please tell me, that's at least in the chat box.
Eagle.
Yeah, eagle, yes, you're right. But another term, it resembles eagle, but its name is not that.
Falcon.
Yeah, falcon, you're right. Yes. And falcon is a national bird of which all countries? A few countries considers falcon as their national bird. I'll give you a hint. Uh, these countries are like GCC countries. So let's play a game. I'll make you guys guess. So the first country's name starts with S. It's a GCC country.
Saudi Arabia.
Yes, Saudi Arabia. You're right. Then the next country, uh, it starts with Q. I think so. I don't correctly remember the order. Q.
Kuwait.
No. Kuwait starts with A
Qatar.
actually. Yeah, Qatar. Yes. Then the next country starts with O.
Oman.
Oman.
Yeah. Then this country, I don't think you guys will get it, but just give it a try. Why?
Yemen.
Yes, you're right. So now the session is being more interesting. Okay, and the next country starts with U, and this country is what we're going to talk about.
UAE.
UAE, yes. So these are the countries that considers falcon as their national bird. So we are going to discuss about UAE. We are going to discuss about a structure that was constructed during the Expo 2020. That is, that represented United Arab Emirates in Expo 2020. So can you guys guess what this picture depicts? Any idea? I've given the hints just now. Have you guys seen it? How many of them have visited UAE? Okay, I'll tell you. It was the biggest event of UAE. Now you can tell, right?
Expo 2020.
Yes, right. It's the Expo 2020, Dubai's, picture. It was held from 1st October 2021 to 31st March 2022. And this is the UAE Pavillion. So this is the structure about which we are going to discuss in this webinar. This is the UAE Pavillion. So you guys might be thinking why I was talking about the eagle in the beginning and all. This actually the structure resembles falcon. This structure resembles the shape of a falcon in flight. So the shape of the structure was actually inspired by the shape of a falcon in flight. So that's why it looks like this. And this, this is the feathers. This resembles the feathers of the falcon and all. This is inspired from that design. So I'll be moving about more into that. See, it's actually an iconic structure which was actually created, which was actually, as I told you, represented the United Arab Emirates in the Expo 2020 site. So I'll go about much more detailed about the story, how it evolved and all, how the structure was evolved and the different features of the structure and all. So before moving on to that, I would like to show you guys a video on how the shape was evolved and just an overview of the building. Just around, I'll show you guys around the building. By seeing this video, you guys will get to know more about it. Okay, so I hope you guys might have got a clear-cut idea on how this shape has how this shape came into life, from how the architect actually was inspired to build the structure in this shape. Yeah, so this is about UAE Pavilion. Now, I'll tell you the story of how this design was evolved. So it was basically a 7 months intense design competition, which was conducted by the UAE Ministry of Foreign Affairs. The developers of this project was UAE Ministry of Foreign Affairs, and the National Media Council launched an intense 7 months design competition. So in this competition, world's most celebrated architects, nine most celebrated architects, world's most celebrated architects participated in this contest, and they submitted 11 concepts. So these 11 concepts were evaluated by Masdar, which is Abu Dhabi's renewable energy company. They are also EXPO's program managers. So these concepts was reviewed, and it was reviewed based on how well it expressed the theme of the expo, that is connecting minds and creating future. So what they wanted was that the model must have a distinct UAE feel, and it actually had it had an appropriate balance between the country's past and future. So they wanted a model which actually which really represents UAE. So that's what they wanted. So these concepts, 11 designs were reviewed based on this criteria. And you guys know who is the architect of this structure? I don't think you might guys know. If anyone knows, you can just tell on the chat box. Write it on the chat box. Okay, I'll tell you. Santiago Calatrava, a Spanish architect, was the one behind this, iconic project. He was the one who designed. His concept won the contest. Talking about him, he is actually a Spanish architect. As I told you. He's widely known for his sculptural buildings, bridges, museums, stadiums, railway stations, and all. And basically, he was an artist in the beginning. His amazing talent and passion in art made him pursue a doctorate in architecture. That's how he became an architect. He's not really an architect; he's a structural engineer, sculptor, and even a painter. Yes, I told you he's a painter. He was a painter in the beginning. So his artistic mind made him pursue architecture. So these are some of his engineering marvels. The first one right here is the Milwaukee Art Museum, and the last one is the Alamillo Bridge. I'm not sure whether I'm pronouncing it correctly. It is the Alamillo Bridge, and the first one is the Milwaukee Art Museum. So now I'll move on to some more details about the UAE Pavilion. So the reason why this model was selected was that the falcon actually represented the country, because as you guys know, UAE was a country which was like just plain desert and sand dunes. Nothing but desert was there. Only a few buildings was there in the beginning. Very many years back. From that structure, UAE has evolved. The UAE that you see now is, UAE has evolved to the UAE that you see now. So it was actually a fast, development. So UAE is evolving very fastly. Its speed and its power and strength has made, the UAE that you see today won't be the country that you see 5 years from now. So that development, that change, that evolving, technology of UAE has, Falcon can actually so UAE, the people of UAE claims that Falcon actually represents the country because of its speed, power, and strength. Because it represented the country. So that's the reason why this model was selected. The structure is situated at the heart of a 500-acre exhibition area, and with a built-up, and it's like set in an area of 15,000 square meters with a built-up area of 90,200 square meters. It's comprised of a 2,000 square meter upper floor and a 662 square meter mezzanine with a plaza level. And also, the ground level includes a garden and car park across 13,300 square meters. So it is a 4-story structure. And the peculiarity of the structure is that it's built using renewable energy sources. I'll move on more detailed about this renewable energy sustainability of the building in the upcoming slides. And there's a peculiarity of these wings. It's, as you saw, you guys might have seen in the video, the wings are not just stationary, they are moving. There are 28 of them, and these 28 wings have hydraulical movement in them. So that's the another peculiarity of the building, even about which we'll be discussing in the upcoming slide. Okay, so this I gave you a general overview about the building and its location and all. Okay, now once when the architect told his concept, that is, the developers of the project was the UAE Ministry of Foreign Affairs, and then they launched the competition, and then the architect proposed the model. That is the concept. His concept was freeze. So after the building became famous, if we search in the internet and all, we'll see the name of the architect. Not only this building, every building is the same in the case. Only the ones who dug deep about it will know about the different other people who was involved in this project. But not only the architect, there are several other people who were behind this project. That is the structural engineers, the MEP team, then the project managers and different other various people were involved. They are equally important as the architect, without whom this project won't stand in this question in an accurate way, because the strength parameters and all are decided by the structural engineers, without whom the project won't come into life. The mechanical, electrical, plumbing, or everyone is equally important. So I'll just introduce you guys about the different stakeholders that were involved in the project. So as I told you, initially the developers, that is the UAE Ministry of Foreign Affairs, they were the one who came out with this idea that they wanted a unique structure that represented the United Arab Emirates in the World International Event. So the architect, the San Diego Calatrava, was chosen as the architect. Then comes the steel structural engineers. That is this building, that the wings and all that you saw, it's comprised of steel. The entire structure is made of steel. It is a steel structure. So it is a complex steel structure. So that structural steel design was done by the Gulf Steel Industries. Then comes the MEP contractors. The MEP contractors were Emirates Falcon Electromechanical Company. With this, the design and analysis stage is almost over. So after this design analysis stage, then comes this construction stage. So that is the construction project managers, site supervisors and all. So the main contractors of the project were Arabtech Construction. So Arabtech Construction were the main contractors. Then not only these stakeholders, there are several other people who work behind this engineering marvel. Numerous other people. We can't actually tell the names of everyone over here, but these are some of the main people. Then there is another consultancy agency, WME by Aegis Group, and they were in charge of full site supervision, then sustainable design and all. With the help of the WME by Aegis Group, the sustainable design was done. As I said, I'll go more detailed about the sustainable design and all in the upcoming slides. Yeah, so these were the different people who were involved in the project other than the architect. So talking about this steel structural design, as I told you, it is a steel building, steel structural building. So this design was done in Tekla software. So Tekla is basically a BIM software with which we can able to model structures that incorporate different kinds of building materials like steel, concrete, timber, and glass. So it's like modeling using Tekla will actually give us an information-rich model, and it's very intuitive and easy to use using Tekla, and also we'll get a very high detailed model. So these are some of the images of the model that after designing in the Tekla software. This is the steel structure of the building, and this is the image of the building that after constructing it on the site, this is how it looked like, the steel structure. So these are the various connections between the elements, structural elements. So this is basically the structural images in the Tekla software. So I'll take you guys through another video where you'll be able to see the structural model. That is how it looked like after modeling it in the Tekla software. Okay. Yes, so after seeing this video, you guys might have got an idea on how complex the design was. Actually, resembling, constructing a building in the shape of a bird, it's not an easy task because from the architectural point of the view, also and the structural point of the view is actually much more difficult and critical because the structural engineers will have to keep the connections in the structure, and the different elements and all they have created custom made elements have to be incorporated in the structure. So that's too.
Ma'am, we can't see the screen, ma'am. We can't see the screen.
You can see the screen?
Can
you see it now?
Is it visible for everybody?
Yeah. You can't see it?
Yes, we can.
Okay,
Okay,
then maybe
fine.
I cannot. All right. I cannot see it.
It's actually visible for everyone. Okay. So, yeah, talking about the structural details. So, okay, where are we? Yeah, about the connections and all. Yeah, so after seeing the video, you might have got a clear-cut idea on how complex the design was. Yes, the design was very complex, and it was done by Gulf Steel Industries, and they got and this structure was actually awarded Tekla BIM Awards. The structure was awarded because of this complex design. It was very brilliant design. It was done by the Gulf Steel Industries, and the tools that were used to model the structure was Tekla structures and Tekla BIM. These were the two Tekla tools that were used in order to model. The overall steel was over 2,500 tons. And actually, the challenges that were associated with this structural model. Okay, you might know that there will be a numerous challenges that will be associated with this kind of structure, because it's too complex. So the first challenges was the time schedule was very pressed. By reading the articles and all, I came to know that the time schedule given for different stakeholders that worked behind this project they didn't had enough time to actually design this construction project. The time schedule was very pressed. So they didn't actually had time to do the trials. That is, they once modeled, the model must be perfect. The perfect model must be given to the people who are working in the site. The structure must not have any defects, or the model must not have any defects or any clash issues and all. So for creating such a perfect model on the web, on the software, such an advanced software is necessary. That's the reason why Tekla was chosen. And the next challenge was that most of the building, okay, as I told you a while before, that the connections and all, the connections and beams and all that were used inside this model, the conventional connections wasn't, we weren't, like, they weren't able to give conventional connections in this complex model because that wasn't, that didn't fit in here. So custom-made connections were needed to develop in order to build the structure. So all these facilities, Tekla only provided. Tekla was a software that provided all these facilities. That's the reason why Tekla was used in order to model this complex structure. So using Tekla, we get a visual information-rich model with a very high level of detail. And also with all the information at hand, it's an information-rich model, as I told you. And it's easy to create and store. Even we can change it very easily. That is, if we have any alterations in the model, we can change it very easily without affecting any other factors. Also, better collaboration. Also, Tekla allows better collaboration, and also data extraction is very easy using Tekla, and it's very easily interoperable with other softwares and tools. So these are some of the advantages of Tekla software and why Tekla was chosen to actually model the structure. Now, let's move on to some of the features of the project. That is, as I told you, there are several other features. Okay, the elements of the building, were not really constructed to attract the visitors. That is, different elements like the wings and all, as I told you about the movable wings and all, they were not really constructed in order to attract the visitors. That is, they were not really aesthetically pleasing. They were one of the other functionalities lying behind each and every elements of the building that the you guys might have not noticed. Okay, before going into that, can I ask you, like, how many of them have visited this Expo 2020 UAE? Is there anyone? Just you can reply in the chat box. Is there anyone who have visited the UAE Expo? Come on, guys, speak up. Just write in the chat box. If it's no, it's fine. Just write it no, so that I can, even tell you more about detailed. Okay, you guys have not visited, yeah. So it's fine. Yeah. So actually, even if we visited the building, we might not even notice all these features. We'll be amused by the structure and the movement of the wings and all, but we won't be able to know the the features or the functionality behind all these elements. So yeah. So firstly, I'm going to talk about the 28 openable carbon wings restructure. That is, these wings that you can see in this picture, these are actually openable. So they actually adjust themselves between, they position themselves covering a range of 110 to 125 degrees, and they can be opened in 3 minutes. So within 3 minutes, they can be opened. And, speaking about it technically, it is activated by using 46 hydraulic actuators. So these 46 hydraulic actuators activate the rotation of these wings. So these hydraulic actuators function as pistons. So when the hydraulic oil is pushed through these actuators, they extend, resulting on the opening of the wings to their full capacity. So this is a mechanism behind the opening of these wings. And also they got a sense. These wings have got sensors in them, so that they can, they open it automatically. So that the light, the sensors are actually there to adjust the lighting. That is, depending upon the position of the sun, these wings open and close automatically. And also, these wings have got built-in solar panels in them. So this solar panels harvest the energy while it's open. That is, during the daytime, this will be open, and this solar panels will harvest the energy, and the electricity is created using it. This electricity is supplied to the main power grid, and the lighting and HVAC systems use this electricity to function the building. So that's another feature. Isn't it amazing, guys? And also during night, what happened? Not only during night, in the case of any rain or sandstorms, these wings close themselves to protect the solar panels from these sandstorms and rain. So that's all about the wings. Now, the next feature is the ocular skylight. The ocular skylight of the structure. It is situated at the apex of the roof, and it is 37.8-meter high from the ground with a diameter of 12 meters. So the ones who have visited the expo might have noticed it, but actually this ocular skylight mirrors the Expo 2020 logo. So the ones who have visited might have noticed it, but they might have thought that this ocular skylight is actually constructed in order to only reflect the Expo 2020 logo and to show the people the logo. But no, they are surrounded with grills. These grills actually open and extract smoke in the case of accidental fire. They have also fixed insulated glazing unit system in them. That's why it shines like that. Now, the next feature is the auditorium with lifting platform. So there's a faceted sphere-like shaped auditorium which is situated in the center of the building. This auditorium has got a lifting platform in it. So once when the people enter the auditorium, they'll enter through. It actually has seating inside the platform, and also it accommodates around 200 people. So once when the people enter in the auditorium, they'll get lifted through their audiovisual experience, and they get transferred from one floor to another. So during the audiovisual experience, they get transferred, and they'll be exiting the auditorium through another floor. So that's the another feature of this auditorium. The overall height of this is 20 meters, and the outer diameter is 25 meters. And now another feature. Now I'm going to talk about the sustainability details of the building. The sustainability, what all are the practices that the building has adopted in order to induce sustainability into the building. Because the UAE people of UAE wanted to actually represent, that is, make a structure which represented UAE. That structure not only they wanted it to not only be aesthetically pleasing, they wanted it to be a functional building which actually other people can mimic in their construction. That is, it should not have any environmental impact when it actually use less amount of energy. Then inside the building, they wanted occupant comfort and all. So that's what the people of UAE wanted. That's what they wanted while they initially thought about a structure that represented the country. So that's the reason why the building is designed using renewable energy sources. While selecting the materials for constructing the building, they selected the materials that actually have emitted less amount of carbon, that is with low carbon footprint. And also most of the recycled content was actually used in the construction of this building. Then another sustainability practice was that they had wind turbines on the roof. That is, vertical axis wind turbines were there, and these vertical axis wind turbines were used to generate electricity using the wind energy, and this electricity was supplied to the main power grid in order to function the building. And there were solar panels in the wing pockets. I told you about that. Then there was this vertical farming system, that is, vertical farms were there using hydroponic technology. So hydroponic technology means growing plants in a limited space with a minimal water usage. So the building was actually surrounded with a vertical farm. There were many plants were planted which had historical importance to the country. So they planted these plants surrounding the building in order to have in order to welcome the people with fresh air and all, and also to show them that planting can be done with less amount of water and even in a minimal space. We have excuses. We always tell that we don't have space to grow plants, but no, we can even plant them in a minimal space. That's what they try to show by planting different species of plants in their structure. Due to all these features, they had got a LEED Platinum certification. So LEED certification means it is the certification provided by the US Building Council for sustainability. It is the highest level of certification provided by highest level of certification for sustainability. So by hearing that, you guys might got an idea like how well that they have incorporated the sustainability aspects into the building to get this highest level of certification in the world. Then there's this BREEAM certification. This certification is also related to sustainability. BREEAM means Building Research Establishment Environmental Assessment Methodology. So they had this BREEAM certification also. Then there was this rainwater harvesting system incorporated in the building. It collected and stored rainwater, and this water was used for irrigational purposes and other non-potable applications. So actually, it was constructed in order to reduce the building's dependence on municipal water needs, municipal water, and to promote sustainable water management practices. Then there were this natural ventilation like operable windows and lowers, and in order to enhance the occupant comfort and improve the indoor air quality, natural windows and all were used, so that the building didn't needed to actually depend on external energy sources for lighting and all, and lighting and HVAC systems and all. I mean, they needed it, but the amount of energy that is required can be reduced by natural ventilation. That is mechanical ventilators and all. The use of mechanical ventilators and all were not there in the building since it had natural ventilation in it. And also energy efficient components like high efficiency chillers, pumps, and fans. All the materials incorporated in the building were energy efficient in order to reduce the amount of energy that they consume. And also the HVAC system of the building used VRF. VRF is actually variable refrigerant flow. VRF is an individualized temperature control system. That is, in different zones of the building, the temperature will be controlled depending upon the presence of the people in that particular area. Not automatically, there will be VRF. That is, VRF systems will be there. So depending if there is if there are no people in a particular area, then the HVAC system or the air conditioning system of that area can be switched off, so that we can save the electricity. We don't need to actually switch on the AC in the entire building. So that was the another feature that was incorporated, and by using this VRF, the energy consumption was reduced up to 30% compared to the traditional HVAC systems. Then okay. Now I'm going to discuss about certain smart building techniques. So the UAE Pavillion at the EXPO 2020 actually incorporated several smart building functions to enhance the occupant comfort, to reduce the energy consumption, and also to improve the building's performance. So the first one is it is the advanced building automation system. So the advanced building automation system actually monitors and controls the various building systems, including the HVAC and HVAC systems and lighting systems. And the system actually uses sensors and analytics to optimize the building performance and to reduce the energy consumption and enhance the occupant comfort and all. So this was the advanced building automation system. Then there was this occupancy sensors. These occupancy sensors were incorporated in the building to detect the presence of the people. So depending upon the presence of the people, the HVAC system and lightings were controlled, thereby reducing the amount of energy that was needed to be consumed. Then the building's facade incorporated smart shading system. As I told you in the beginning, the wings of the building, that is they had a movement, right? So there were sensors inside those wings, so that this movement was actually automatic. That is, depending upon the position of sun, these wings adjusted their position in order to adjust the lighting inside the building. That is, so that it ensured that sufficient lighting is present inside the building, again to enhance the enhance the comfort of the people inside the building. Then there was this real-time energy monitoring system, where the building operators could actually have insights on the energy usage patterns, and allowing them to identify the opportunity to save energy and improve the efficiency. And also they haven't actually missed a small chance in where they could save the energy, and also improve the efficiency of the building. So in each and every place they have incorporated some or the other feature in order to make the building an effective one. And also there were interactive displays in the building. So these interactive displays actually allowed even the visitors to know about the sustainability features that the building had, and also they were even able to know the energy that the building consumed, the amount of energy that the building is using currently and all. So not only the operators, the visitors were also even able to see that, so that they'll be inspired with this design, and in the future, if they construct a building for them, they can actually incorporate all these ideas into it. So that was the another smart building technique. Now moving on to a certain biodiversity approach that the building adopted. Mm, First one is the native landscaping. So as I told you earlier, the building had native plant species in them. To actually represent UAE, and also to show the people, to show the world the importance of farming and planting species and all, planting trees and all. And there was this second picture that you see over here is a name Al Falaj. The technique is Al Falaj, which was used in the early 70s by the people of UAE itself, to actually channel water from wells, from the hills to the desert. So this is another feature of this thing. So when we enter the pavilion, these things actually welcome us. As you can see in the pictures, this is the entrance of the pavilion. So these things actually welcome us. So we'll have we'll have a warm feeling and a calm environment, with which will be welcomed with fresh air and all. Then there was a green roof system that helps to reduce the urban heat and effect, and also that provided natural habitat for wildlife and all. Then the water conservation system was there, that will preserve the local ecosystem, that is the local water bodies. They weren't they were not needed to actually depend on the local water bodies, so that they'll be reserved. Then there was sustainable transportation, that is in the ground floor of the building. The basement, I think it was the basement of the building. They had bicycle parking. They provided bicycle parking to promote, non-energy vehicle usage of vehicles that had emitted no energy. I mean, consumed no energy and had no environmental impact. Then they even promoted the usage of public transportation to reduce the emission of energy. I mean, emission of carbon and all. So these are various biodiversity approach. Then we go to the building adaptability. That is, the project was actually delivered to LOD 300 in BIM. I don't think you might. I don't know if whether you guys know what is LOD and all. I'll explain about it in the upcoming slides. That is, okay, with a very low clash. So apart from being a sustainable, highly sustainable architectural centerpiece of Expo 2020, Expo 2020 UAE site, it had a very low clash tolerance. Actually, that is, a series of precast structural beams were used in the construction of the building at the basement that supported the upper floors. So these beams were precast, they had this risk of clashes. That is, since the precast beams were used in the site, uh, we have to design it accurately in order to prevent the clashes and all. So there is risk of clashes, which was needed to be eliminated. And also the beams and all, there several openings were needed to be given onto the beams. So the size of the openings needed to be reduced, because we can't have large openings on the beams and all, because it will actually affect the strength of the beams. So the size of the beams, openings for the beams also need to be reduced. That is, while incorporating these precast structural beams, several openings had needed to be given on the site. So we did a better planning. Actually, building information modeling helped in eliminating all these clashes and selecting the minimum opening size for the buildings when delivered to the site. So that's how the building information modeling helped. That is, building information modeling actually has several softwares to detect all these clashes, and building information modeling provides a zero error intelligent model. Okay. Now moving on to some of the challenges of the project. So as I told you in the steel structural design of that is when I talked about the Tekla, I told you guys about various challenges that the Tekla, that is the steel structural design had. Similarly, the entire project had the same challenges. That is the tight schedule. That is, like there were only little room for delays and unexpected issues. There unexpected issues and all was actually not allowed for this project because the time that is allowed for the project was very less. So, you know, um after modeling the project, the model must be that accurate because during the construction of the project on the site, if there's any problem, the or if like normally when we're constructing a building on the site, if there's any problem, then what we do is we'll demolish that particular part of the building and then we'll construct from the start. So we didn't had that this the people behind this project didn't had that time of like starting it from the scratch. No, the models must be that accurate because they didn't had time to for correcting the errors. So that was one of the challenges of the project. Then the site constraint, as I told you, it was this very the site actually wasn't that big for this complex project to be situated. So there was several site constraints. That is, the people behind this project needed to plan efficiently in order for the building to all the features, not only the building, the surrounding the building, the various facilities were there. So that everything must be planned effectively and positioned correctly on the site, despite the site constraints. So that was the other challenge. Then design complexity, yes, as you saw in the structural design, the complex design was very complex. The design of the building was very complex and it had unique features. So the complex design and all, we can't actually do it manually or in any other software, which does not like any other old softwares. We need some new concept or new digitally, accurate software with a lot of information. So it overall we required careful planning and execution. Then only that will only lead to the successful delivery of the project on the site. So by hearing all these challenges, you might actually now understand what was the benefits of BIM, like how BIM actually really helped. These challenges were, or the only solution for all these challenges was building information modeling. So yes, how BIM helped in actually overcoming all these challenges. So as I told you, the time limit was the time limit was very short. That is, the time provided for the different stakeholders was very less. So within this limited time, the stakeholders had to construct by in better collaboration. That is different people. That is the architect, the structural engineers, the MEP people. Everyone must have a connection between better collaboration and coordination between them. Then only we'll be able to successfully deliver the project because for the structural engineers to for the structural engineers, they might need to know the details about the model and all. So they need to have a better communication with the architect. Then only because while modeling they'll have several doubts or several queries regarding the model. So they'll have to have a better communication. Not only the structural engineers and the architects, every stakeholders within each other, they needed better collaboration, which BIM allowed. That is, there is BIM 360 Cloud, where different stakeholders could actually upload their models, their respective models, and everyone can view what other people are working on, so that their doubts can be clear, and even they'll be able to communicate with each other if they got any queries, so that everyone can see what other people are working on. So not everyone, like the stakeholders actually. So that thereby we can actually save the time, because if we don't have any connection between each other, then that will be a problem. There are chances of defects in these designs. So and also efficient planning, and thereby it helps in efficient planning and error reduction by okay. And also BIM allows to oversee the project virtually. That is, as I told in the beginning, we'll be able to see the model virtually as how it is constructed on site, just as how it is constructed on site with every features. It is BIM provides information rich models. We'll have each and every information. So if there are any errors or defects in the model, we can actually oversee it in the model itself, that is in the software itself, and the software will also have solutions for the same, and to actually rectify the errors and all. So that actually helps. Then after completing the model, we can start modeling it on this, constructing it on the site without there won't be any errors based in the mod. So that was the another advantage of BIM and how BIM helped in overcoming these challenges.
Hello. 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 We are not able to hear you.
Oh, sorry. I don't know. The my mic. Unfortunately, it got
Yeah,
unmuted.
past, around 3 minutes, we were not able to hear you.
Okay, till where did you hear? Sorry, it was a technical problem. My mic. I don't know how it got muted. Till where did you hear? Can you tell me?
Yeah, only the last part.
Oh, this one.
This is also, it was clear.
Okay, I was like, okay, you heard the starting of this slide, right?
Yeah, the last part only we were missing.
Okay, fine. Thank you for informing me. Um, yeah. Now it's okay, right? My voice.
Yes, now we can. And it's showing us a 5 minutes left in your meeting. Is it okay? The timing?
Uh, I'll just ask and tell you.
Okay.
Wait a second. Okay, so the technical team will resolve the issue. So no worries, they'll do. If any problem comes, they'll do it.
Okay.
Okay. So yeah, so actually, BIM allowed better collaboration between different stakeholders and all. As I told you, then highly complex projects was able to be created and designed in BIM using advanced softwares like Revit, Tekla, and all, as I told you in the previous slides. So these softwares actually helped in designing the complex projects with many features in them. And also, so you guys might think that this complex designs will be very difficult to be modeled in the software. No, they allowed actually easy modeling of the softwares. So anyone could be able, not anyone, the ones who the technical people, that is the professionals and all, it will be their work actually was made simpler. Okay, so that's how the complexity of the project was overcome. The limitation of the complexity was overcome by the building information modeling. Uh, okay, and also since the site constraint, talking about the site constraint problem of site constraint was also resolved, because as I told you, we can virtually view the entire site and the entire building and the surrounding of the building inside the BIM. Everything we can decide design inside the BIM. That is in the Revit software and all. Not only the building, the site that surrounds the building, the trees, the plants, each and every plants, everything can be designed. So we can actually plan it accordingly. If the site is small, then we can effectively use a site by placing appropriate like appropriate different elements and different parts of the building in the appropriate positions, and positioning the building accurately, and surrounding the building, the various other facilities, amenities and all. We can actually model it accurately on site by using BIM, because we are seeing the model virtually. So that actually helps very it's really very helpful. Okay, now we can move on to BIM, the building information modeling cycle. So initially when the webinar was started, I told you about the building information modeling. It is a cyclic process. Wait a minute, I'll get back to you. Yeah, so the cycle, I'm going to explain to you guys the cyclic process of BIM. That is, initially, okay, I'll explain with the example, previous example that I told. So initially, there'll be a conceptual design. So the conceptual design, that is, you might relate with the one that I told you in the beginning. The conceptual design is provided by the, that is from the exam, taking the example of the UAE Pavillion. The architect Santiago Calatrava was the one who did the conceptual design, and his conceptual design actually won the contest, and it was selected. So once the conceptual design is freezed, then the detailed designing is done. So conceptual design is done using various softwares. I'll move on to that softwares and all in the upcoming slides. After the conceptual design, the detailed design will be, designing part will be done. So detailed designing part means it's structural design, mechanical, electrical, plumbing works and all. The detailed modeling, modeling of the building. That is, every details related to the building will be designed in the detailed design stage. The third stage is the analysis stage. Analysis stage is actually after doing the design process. In the analysis stage, that is, for example, I told you different people are involved in the project, so different stakeholders are involved in the project. So these different stakeholders, they're doing the project in their own, like they do their project, and they do their design. There is the architects will do the architectural work, the structural engineers will do the structural detailing, the mechanical MEP team will be doing their MEP works and all. So when all these different disciplines come together, we have to check for clashes. That is, whether a beam overlaps to another duct or pipe, so everything. So these are actually very critical. So that clash and all has to be detected. That's what we are doing in the analysis part. It is clash detection. And also, not only the clash detection, the structural analysis, that is the structural model and all, has to be analyzed with respect to the strength and all. So that BIM allows, so for all these, for all these stages, even for each and every stage, there are numerous softwares that we use for these doing all these functions. So that is the analysis part. Then comes the documentation. So documentation is nothing but, since you're working professionals, you might know what is documentation and all. In documentation, actually, the model, that is the design team, the model of the design team is actually communicated through the documentation. So that is, these documents are used by the project managers and site supervisors to construct in the construction site. That is the communication. It's a means of communication with the designers and the contractors. So that's the documentation part. Then fabrication means we can actually with the BIM we can actually use the prefabricated elements. Prefabricated is the elements that are previously fabricated from another factories that can be transported onto the site and can be used. As I told you, BIM allows room for clash detection. These elements can be actually checked for clashes prior to delivering it on the site. In the software itself, we can check, and if there are any clashes, these clashes can be resolved also. That's how the allowing the use of fabricated elements. That's how BIM allows the usage of fabricated elements. Then comes the construction 4D, 5D, and all. So 3D construction 3D means only the 3D model. Construction 4D means the time the time parameter is incorporated into that model. 5D means cost is incorporated into that model. Then the construction logistics part. Construction logistics means, for example, if a concrete work is going to happen on a particular area, then on a particular construction site, then for that concrete work to happen, the amount of resources, so that the resources that are needed for that work to happen, that everything that is the ensuring of the resources. That is what is the construction logistics means. That is, if appropriate, it is correct amount of resources, it is correct different what all other things that are required for that concrete work to be successfully done on that particular day. So we can ensure that using the building information modeling. Then comes the operation and maintenance stage. So there the construction stages of work. Then the building is successfully delivered to the people. Then after the construction of the building, then comes the operation and maintenance stage. That is the life of the materials that are being used in the building and all. So the operational maintenance stage also we can do it in the building information modeling. I told you about the detailed design, right? So using the detailed design, while doing the detailed design, we have to actually incorporate much more informations about the building into the while designing itself. That is, for example, if you take a wall, if we take an example of a wall, um, we can actually give all thermal properties, several other properties of the wall while designing itself. So it will actually be helpful in the operational maintenance stage. How means that is the life of the wall. So when the wall is, I'm just giving an example I've just taken an example. That is the life of the wall. If its properties, that is, while giving all the properties, we can actually the software itself tells that the wall is critical now. After several years, the wall is critical, so it is needed to be renovated or demolished and all. So the software, by using the software, we'll be able to know that, and the particular location of the wall, this floors, this room's wall is critical, so you'll have to change it, and all that stuff can be done. So the operational maintenance stage can be done using building information modeling. So after the operational maintenance, then comes after several years, we can either renovate the building or demolish the building. Renovation and demolition, everything the BIM allows. The BIM helps in doing all these things effectively. The programming stage is nothing but certain repetitive models. That is, certain models will be repetitive, or similar models will be there. So the repetitive models and all can be created using computer programs. Not only the repetitive models, the regular models, regular buildings and all, without manually drawing it in the software, or a person with like giving all the details, drawing the wall, giving the doors, windows and all. Even without doing that, we can actually create the model by using several computer programming techniques. BIM has softwares for these also. That is Dynamo and all. It's really complex, and an IT person will be only able to do it. Not only the IT person, others can also do it, but it will be more easier for them. So see how the technology is progressing. So after a few years, I don't think we'll be able to do this. People will do the manual drawing of the walls, plans, and all. I think everyone will be switching onto the programming, because the work will be completed in lesser than half of the time required for the requirement compared to the manual modeling in using the softwares. So that's how the cycle goes. Now, this is a CAD workflow. Before BIM, before building information modeling, AutoCAD was used. This is like the CAD workflow. Only 2D elements were incorporated in the CAD. That is the floor plans, elevation, section, and all. And 3D was also there, but no, CAD workflow didn't had control over budget, time, and all. And project management part was we can't do anything about the project management about project management part using the CAD. So that was the limitation, and we actually needed a better workflow, because using Revit, the changes, for example, I told you these views, floor plans, elevation, sections, detail views, schedules, and all. So in CAD, like if there's any change in a particular model, that is, if there's any change in the floor plans, then it has to be changed in each and every view. It is elevation, sections, detail view. Every views, we have to take each and every view, and we have to make that change in these views. So, but Revit is not like that. If we make a change in any of the plan or any of the view, that change will automatically gets updated in all the views, all the legends, color legends, schedules, detail views, every views in the entire model. That change will be reflected. So that's the advantage of BIM. So and that was a problem of CAD. Then the coordination and clash checking wasn't able to be done in the CAD workflow because traditionally people used to trace sheets to see whether any beam or column or any um, the ducts and all overlap with each other, but that is actually not a good idea to do check for clashes, because even if after doing all these things there were problem of clashes on the site, then of course the time management aspect is not incorporated in CAD. Then cost estimation was there, but we had to do the manual estimation, so it actually was very time consuming, and also there were chances of human errors in manual cost estimation. Then energy efficiency, no way, no energy efficiency aspect was there in CAD. So these are the several countries that adopted, that made BIM as a mandatory. That is like now we have started hearing about BIM recently, not recently, a few years back, right? But that's not in the case of several other countries, because see, scan here. The countries that are marked in the red are the countries that have made BIM mandate, that most of the construction projects of that country has to be constructed using the building information modeling. The blue countries are the countries that use BIM, but not the usage has not become that wide as compared to the other countries. Okay, the first country is Scandinavia. You can see that Norway, Sweden, Finland, and Denmark and all, they adopted BIM since 2002. See, now it's 2023. Only a few years back we knew about BIM, but they adopted it since 2002. And UK also was the global leaders. That is, BIM was mandatory since 2016. Then USA since 2008. In 2008 it was introduced, and the adoption rate is accelerating. Then countries like UAE, Australia, and all, they also adopt. That UAE is being adopted BIM. Most of its projects, United Arab Emirates, are constructed using BIM. That is the projects that we see now. The new projects that is being launched each and every year. Every project is constructed using BIM, since it is marked in blue. So even now we have to grow, that we have to incorporate this building information modeling in all the projects that we do. That's the level of construction that we have to reach, because it has got all the energy analysis and sustainability features and all. Building information modeling has got. So UA has made BIM mandatory since 2014 for projects greater than 40 stories or 3 lakh square feet. Yeah. So these are the several countries that has made BIM mandatory. Now I'll be taking you guys through the workflow. I told you about the workflow, BIM workflow and the cycle. So I'll explain to you guys which all are the different tools that are used in the each and every stages of building information modeling. That how all these features, all the designing purpose and all are done using which software. So initially I told about the conceptual design. The conceptual design that the architect Sanuga Kalatrava gave with which he won the competition. So the conceptual design was done using, usually the conceptual design is used to be done using SketchUp, BritSCAD for Autodesk permits and all. Then I told you about the programming part. Programming, that is, we could create models using programming by certain algorithms and all. By using basic programming techniques and all, we could create complex building components and all. So these are the softwares that help in programming. That is the Grasshopper, Autodesk Dynamo, many generative components and all. These are the various softwares that help in modeling the buildings using programming. Now, when moving on to the detailed design aspect, there are several detailed designing. That is the architectural model, structural model, then the MEP, mechanical, electrical, and plumbing, collectively known as MEP. All these different detailed design is done using different softwares. Yeah. These are the aspects that come under the architectural modeling. That is the space planning, estimation, interior designing, visualization. So under the architectural modeling, the detailed architectural modeling is the space planning, estimation, interior designing and all, visualization and all. Then the structural aspect, moving on to structural aspect, RCC modeling, RCC detailing, estimation, foundation, steel modeling and all come under it. Then the MEP modeling, mechanical, electrical, plumbing systems and all. The civil and infrastructure modeling, the detailed modeling means transportation modeling and detailing, then bridges, railway, metro designing and all. And then comes the geotechnical designing and all. So these are some of the detailed designing aspects. These are the softwares that are used for detailed design. That is, in the Revit itself, we can do the detailed design. Revit structure and all is there. Revit architecture, Revit structure and all helps us to do the detailed designing. Then the Graphisoft, ArchiCAD, Bentley, Open Buildings, BricsCAD building. These are the tech class structures and all. Then coming on to the analysis part, as I told you guys, there are various analysis softwares that helps us to do the clash checking, clash detection, and even the structural analysis softwares. Then even we can do the building energy analysis. As I told you, if while modeling, if we give much more information about the project, then we will be able to do the energy analysis part also, the lighting, solar, coordination checking, everything. So these are various softwares that are used for structural analysis. That is the STAT Pro, ETAPS, SAP, SAFE, Plaxis, Medas, and all. Then these are the energy analysis softwares. That is Autodesk Green Building Studio, Autodesk Insight, Builder, Open Studio, Design Builder, Open Studio, Bentley, Heathercomb, and all. Then comes the documentation part. So as I told you, documentation means a means of communication between the architect and the site supervisor, or the ones who construct the project, or I mean contractor, not site supervisor, or contractor. So there are different kinds of construction drawings, that is the design drawings, construction documentation, issue for construction drawings. So once the drawings are, the designing part is done, we have to get the authorization from the, the license from the authority and all, the signature from the authority and all. So for that, we have to do the issue drawings and all. So that is the other type of drawing. Then as-built drawings. As-built drawings are drawings that are created after the construction work is complete. Then the schedules, estimation reports and all. So the AutoCAD, Bentley, MicroStation, BricsCAD and all the different various softwares that are used for documentation. Then moving on to the fabrication. For structural fabrication and MEP fabrication are there. So these are the softwares that come under the structural and MEP fabrication. You can view all these softwares and their icons in the slide. Then comes the construction 4D, 5D and all. As I told you, construction. There's a slide where I'll discuss more about different dimensions of the construction. In the 3D, only the 3D aspect will come. In the 4D means the time incorporation of time will be also there. In the 5D, the cost, that is, we will be able to calculate the cost and adjust the project budget and all. So this is about construction 3D, 4D, 5D and all. Yeah, construction planning, project management, clash detection and coordination, 5D cost planning and all. So these are the softwares that are used for construction 4D, 5D. That is Autodesk BIM 360, BIM 360 and all. We can actually schedule the project. That is, there are much more, like moving into more detail into that, actually takes more time. There are various features related to this BIM 360, then where we can actually manage the projects and to complete it on time. Then where the site supervisors and the officials can communicate with each other. That is, for example, I'll just tell you a small example. If there is any, there are BIM 360 field and layout apps. That is, if there is any defect on the site, the site supervisor can take a photo and then upload it in the app, and the other officials or the people who did the model can actually review the issue, and then they can advise the solutions. Thereby, the problem can be resolved on the spot itself. Then comes the construction logistics. I told you what is construction logistics and all, and this is softwares are used for construction logistics, Vico and all. Then coming on to the operation maintenance, it is a 7D BIM. Okay, asset service, facility management, service tickets, documentation, Bentley, Autodesk BIM 360. In the operational maintenance stage, BIM 360 helps. Then the demolition stage. Actually, I told you in the operational maintenance stage, the BIM building information modeling helps. that is the life of each and every element of the building can be predicted. I mean, can be if any of the building element is defective, the software will tell us that this is life of the building. It does needed to be, changed or demolished or renovated. So by using that, we can know about it. While the demolition works are carried out, we can use the software to predict the amount of waste that is being generated after the demolition work, and so that we can do the pickup truck requirements and waste disposal, charging free for different waste facilities and all, and also waste recycle and reuse can be planned while by using the BIM, because we'll know what are the materials that are used and how can be recycled and all. So it can be planned effectively, and how much volume of waste will be generated and all will be detailed waste estimation and planning can be done by using building information modeling. So that's how it helps in demolition. Mm. Okay, in renovation, in coming on to the talking about renovation, actually 3D laser scanners are used. There are 3D laser scanners. So using 3D laser scanners, we can actually scan the entire building. And for example, for the buildings which the data, there is a plans and all are not available. There is old buildings and all. And if you want to renovate that building, then we need to have on like as-built drawing of the building. So in order to have an as-built drawing of the building, we'll have to scan. There's a technique called 3D laser scanning. So the 3D laser scanners are actually placed inside the building, and the building is completely scanned, and we can actually get a point cloud model of the building, and this point cloud model can be opened in recap software and thereby exporting it in Revit. Using Revit, we can import this precast. Recap point cloud model, and this model, by tracing through this model, we can actually create the building, that is create the as-built drawing of the building, and this model can be used for further renovation planning and all, extension and all. Then scan to BIM. So scan is the same as I told about the renovation. It's the same. That is, it's a technique which is used. That is the 3D laser scanners are used to capture the high density point cloud models. Point cloud models will be generated, and that can be opened in the recap, and then we can open that point cloud model in the Revit. So Revit, and then we can trace through the model, and we can plan the renovation and all. Usually not only for renovation, for the buildings that we need data, we require as-built drawings. That is, old monuments and all might not have the plan. We might not have the plan for that old building. So only monuments, old buildings and all. So if we need a plan of that building for planning anything further, we can actually obtain the plan in this manner. That also BIM allows, building information modeling allows. Now, moving on to different dimensions of BIM. So some of the dimensions I told you before. That is, the 3D dimensions means that only the 3D aspect, that is the shape of the building, only the three x, y, z axis will be, only that information will be provided in the 3-dimensional BIM. In the 4-dimensional BIM, it's a digital, adding scheduling information. Scheduling information will be added in the 4D BIM to model this construction sequence. So it actually allows the project team to better visualize how the construction will be sequenced, and also from the contractor point of view, also it's vital. So they can see how it will be sequenced, and by the incorporation of time, within this much time, each and every project can be, each and every part of the project can be finished. It is, the project will be divided in different sequences using Primavera software, and each sequence will be given this much time. So it's coordinated accordingly. Then when it comes to the 5D BIM, the cost aspect will come. That is, within this much budget, the project has to be completed and all. I told you about the 5D BIM in the previous slides. Then there's a 6D BIM, where the sustainability aspect will come into play. That is, sustainability details of the building and all will get in the 6D building drawing. And then in the 7D BIM, the facility management. That is, the facility management means the in which stage of the building the maintenance has to be done. Every details about it will get in the 7-dimensional BIM. Yeah, these are the different dimensions of BIM. Now, you guys, do you remember that I told while explaining about the UAE Pavilion in the Expo, I told a term known as LOD 300, named LOD 300. So I told you that I'll discuss about it in the last. Yes, so that is LOD means level of development. So level of development is nothing but it's a specific way to determine on which stage of a design and development a certain BIM model is. So that's what is development. So there are different levels of development. The first the level of development is LOD 300, LOD 100, which is the conceptual design. So in LOD 100 model, if the model is LOD 100, then only the conceptual design of the model will be present. So that is, we'll only have minute details about the height, width, and as I told you about the concept of designing softwares that are used, SketchUp and all I told, right? So that in using that software, we do the concept of design, where we have only a few information about the height, width, and all, and various other parameters like. Then what? We'll also have the visualization part. We'll also be able to see the visualization part and all in the conceptual design. Then comes the schematic design, LOD 200. LOD 200 means a schematic design. Schematic design means the much more details. When compared to the LOD 100, we have much more details in the schematic design. That is, for example, approximate quantity, size, shape, everything can be will be incorporated in the schematic design. Then comes the LOD 300. LOD 300 is a detailed design. So it's actually the accurate modeling with all the details and informations. And the shop drawings and all comes under LOD 300. So where elements are defined with specific assemblies, precise quantity and all. Precise quantity, size, shape, location and orientation and all. LOD 300 is a detailed design. Then comes the LOD 350. In LOD 350, it's about construction documentation. That is, it's like it's just like LOD 300. Only a minor difference is there with LOD 300, LOD 350. That is model. It has the documentation aspect in it. It is model detail and the element that represents how the building elements interface with various systems, and how other building elements with graphics and written definitions and all. So that's what is construction documentation. Then comes the LOD 400, which gives the details about the fabrication and assembly. That is, in fabrication and assembly, as I told you, that is we can actually use prefabricated models inside our building. So and the assembly and all, we can plan it prior to delivering it to the site. We can plan it, effective planning of the prefabricated elements. So that details about that is in the LOD 400. So with LOD 400, actually till the construction of the project, the LOD 400. Without the construction, till the construction, LOD 400 is there. Then the next one is LOD 500, which is the as-built drawings. That is it is a maximum. LOD 400 is a maximum level of drawing which is used for construction. Then the LOD 500 is the as-built drawing. As-built drawings are the drawings that are used, which like after the construction of the project. The project will have various changes when compared to the original model. So yeah, there will be very like minor changes will be there when compared to the original model. Means original plan. Okay, the initial plan, the as-built, that is building but after constructing it on the site, will have minute changes. So the as-built drawings are the drawings that show, that is after building, as the name suggests, after after completing the project, the model is created after completing the project is known as the as-built drawings, with all the information regarding the existing model. And the as-built drawings will be used for further operation and maintenance stage and all. And also these drawings can be used to compare with the initial model, that is initial plan that is developed, and what we can know what were the different changes that was incorporated in the original project and all. This is an example of what I explained right now. LOD 100, 200, and 300 with a chair. That is for see LOD in LOD 100. We'll only know that the details that marked in red actually is the relevant information for each LODs. So in LOD 100, we'll only able to know that it's an office chair. And also depending upon the different, since it's a small chair, it's like this. When it comes to a big building, the data will change. So when it comes to an office chair, it is the LOD 100. Only we'll be able to know only that it's an office chair. Then in LOD 200, we'll be able to know that it's an office chair. Its width is 700, depth, height, and other details, like minute basic details will be there. So the first one is only the concept. It's the presentation stage. When it comes to LOD 200, it is a design development stage. It is we have an idea about the much more idea about the model. Then comes to documentation. And when it comes to LOD 300, the documentation will come. That is, we'll know that it's an office chair with arms, wheels, and along with the other details, that is width, depth, height, and all. We'll be able to know in the LOD 300. Then much more details will be added. That is everything. Then when it comes to LOD 400 drawings, it is a construction stage. Using the LOD 400, we are doing the construction work, and in the LOD 400, additional details like the manufacturer and all will be added. Manufacturer and the name of the model and all. Then the LOD 500 is the as-built drawings that are used for facilities management, that is the operation and maintenance purposes. And in that, the purchase date and everything will be provided. Much more details, and the differences and the deviations of the model from the initial plan and all will be updated in the LOD 500 model. Yeah. So with this, the session has ended. So do you guys have any doubts or queries? After hearing the session, do you guys have any doubts? If yes, you can ask. Hello. Can you hear me?
We can hear you.
So do you have any doubts?
Yeah, for the MEP part,
Okay.
yeah, how's the integration is possible? Because it will give the full details for the MEP or only for the constructions.
I didn't get you.
No, for MEP part, MEP,
Yeah.
because we are based on MEP.
Okay. So for the MEP part.
Yeah, with as you said, it will give you the full. It will give us the full details, or only for the civil.
No, using Revit, it's not only the architectural modeling. We can do the architectural modeling, structural modeling. There are different tabs in the Revit software. That is, we can do the architectural modeling, structural modeling, and the MEP modeling. So in the MEP part, we can even model the elements just as how it is on the site. That is, the pipes, everything can be modeled, the connections, the mechanical, the plumbing works, everything can be seen and reviewed. We can model it exactly as how the architectural modeling is done.
Mm-hmm.
Using Revit software, everything is possible. Like not only the architectural aspect, every aspect, the steel modeling, even the steel modeling can be done in the Revit. There is a Revit steel tab. So everything, not only the structural and architectural part.
Okay. In what based it is giving the schedule? Because you said scheduling is possible, right? With the project schedule.
Yeah.
So on what basis it is giving the schedule?
Schedule means we can actually obtain information about that is the quantities, that is quantity. For example, if it's a wall, like different the bricks, amount of bricks that are used, so the quantities that are quantity, cost estimation, everything can be done. So likewise, we can obtain the scheduling information. Everything can be, there is room for everything in Revit. Like there are different options where we obtain all these details. We don't need to do it manually. That is manual estimation and all. Don't need to do it manually. There is room for Revit in doing all these scheduling information and all. We'll know the exact information about the materials that are used for constructing, the number of materials that are used, and with that, the Revit itself will calculate the cost required for like everything, estimation, everything, and that will be incorporated into the sheets, and the scheduling information we can attain the scheduling information and all.
So is there any provision to provide man hours Because it is normally the project schedule will depend on the man hours, right?
Yeah, what do you mean manuals?
Man hours, man hours.
Man hours. Okay. So
So is there any provision to provide the man hours time? Because if
yes,
if
yeah,
you are
yeah. There
looking,
is like we can actually using the Primavera software. There is like we can divide the project into different stages. We can different sequence, and in each stage we can give this much time will be required for completing this particular stage. So the site supervisor or the people related construct contractors and all can review it and can plan accordingly. So they'll have an idea on how much time with that particular construction part of the construction will take place and all.
Mhm.
So that's how the man hours can be evaluated.
Okay.
Okay.
Okay, thank you for your session and nice
Yeah.
meeting.
So I'll share a feedback link. So just give your feedbacks on the session. I'll put it in the chat box. So everyone, kindly please do the feedback through that link of this today's session. Whether it was so you guys were able to follow me. Hello.
Yeah, yes, you have.
Okay. Okay. Thank you, guys. Thank you.
Thank you.
And don't forget to actually follow the BIM Labs Instagram, LinkedIn page, and all, because in Instagram page we used to upload many useful information and all. So it will be useful for if you guys follow the Instagram page. Even Instagram, LinkedIn, Facebook, and even we have YouTube channels where we provide live free webinar sessions, like free sessions based on different topics. So your doubts and all will be cleared. So you can subscribe to the YouTube channel also. Okay, that's all. Thank you, guys. Thank you.
Welcome. Thank you.
Thank you so much. You can leave the meeting.
Can I ask you a question?